Okay, hello everyone. Can you all hear me? Yeah, good. Okay, my name's Dan. I am automation architect at Gamma. I learned this morning that there is another Gamma over here. It's a hardware store. That's not that Gamma. It's a different Gamma. We're a UCaaS company that primarily is in the UK but expanding across Europe. We have a lot of stuff going on outside of UCaaS, so if you've not heard of us before, have a look at our website. We've got a thing called Gamma Elements, which is effectively our entire offering, Ethernet and all that good stuff. So it's effectively an ISP, but have a check out of that. So why am I here today? So I'm going to take you on a bit of a journey that I went on over the course of the last year, having joined from one of the biggest ISPs in the country, back in England, BT, through there throughout my whole career, and then moved over to do automation full time. So I'll address some of the challenges that I came across, some of the challenges that we've heard here today, and how we address some of those. So how did I actually get to become an architect? So I started life as an apprentice straight out of college, doing second line support at the time, looking after one of the biggest networks in the UK that carries all of the UK broadband, called Converged Core 21C, mobile, Ethernet, TV, all the good stuff. Disappeared into security for a few years, and then came back out as a third line engineer. So I've done the whole CCNP type route, spending my life basically in Wireshark, and traded that for effectively visual code. I remember how I started on automation. There's a guy called Simon Gates. Some of you may have heard of him, a guy at BT, incredibly clever. We had a piece of work where we had to do something called repaint a customer, thousands of VRFs, effectively change the route target. And I thought, well, this is going to take years, absolute years. This is a job for life. And then he showed me something similar to what you see on screen. That was generated by ChatGPT. I've not written Perl in a good 6 years, so don't come at me for that if it's wrong. He showed me a Perl hash, effectively ran it, and 12 seconds later, everything was done, and instantly I was hooked. And so what I did was I sort of took that and thought, okay, well, if it's that easy to do that, what else can we do? And the use cases just grew and grew and grew. And the same use cases kept coming up. Things like, how many versions do we have in the network? How many routers do we have in the network? And for my old BT colleagues, is it even an MSE? What type of device do we have in the network? And the languages then evolved. We went from Perl into Python as we start to push the boundaries of GUIs and APIs and all that lot. So what I'm actually going to talk about today, everything obviously needs a scope, and we will not deviate from this scope. And actually, that's a really, really important point that we'll address in here of how actually you do sometimes have to deviate from the scope. While this is a case study on my journey, it's a spotlight in automation in general, going from effectively what I found and how we've tackled some real world use cases to actually deliver value. Having worked at two of the biggest telecoms companies in the UK, whilst the scale is different, the desire matches and the challenges are very, very consistent across both. And finally, we'll finish off with some of the automation projects and actually show you some code. So what we'll answer, if you're looking at those questions and thinking, yeah, they sound pretty cool, and even if you've wondered them yourself, then you're in the right place, and trust me, you're not alone. Even though it's my job to answer these questions, even sometimes I sit there and think, what the heck? So you're definitely not alone. I'll go through how we approach these questions and most importantly, the lessons that we followed. So what did I find? Fresh-faced, come out of BT for 15 years, haven't figured out what works really well at scale. And we're talking 30, 40,000 router scale. So really there's nothing that you can't automate when you've done stuff like that. So I headed into Gamma, full of ideas at what offered real value. I understood some of the challenges the company had faced because I'd had some time to think about during my period of in-between jobs, and balanced with my imposter syndrome, which I massively suffer from, and the anxiety of having left a company of 15 years, I went into it going, yeah, okay, this is effectively what I'm going to do. The secret is with imposter syndrome, for anyone else that suffers from this, is you're exactly where you're supposed to be. So after the first few weeks, keen, eager Dan going into the business, these are my themes that I wanted to do. And actually, as we started then uncovering everything, it actually felt quite deflating, because what I found out is what I'd considered network automation had already been done. But the trouble is that when you peel back the layers of all these different things, all these themes, you actually find that they're not done. They haven't really progressed past an MVP. So my first realization actually was automation is quite easy. What is the hard bit is actually making it stick. My second realization was actually it's easy to use these things, but actually it's hard to do it correctly that offers the value. So sure, we had network health checks for a single vendor. We had config compliance for 3 devices. Now I will just address, using Ansible for automated upgrades is completely fine. I don't hate on Ansible. There's a time and a place for it. Point is that things had been started and not necessarily finished. So my third realization is actually, I'm going to have some fun here because it shows that we've got some really, really good people that already understand the need for automation. We just need to figure out how to make it stick. The issue, therefore, wasn't going to be technical. It was actually going to be all to do with culture. So my first challenge coming in was, okay, we clearly know how to automate. Are we automating the right thing? There's a reason why I've been hired, okay? And it's clearly that we need to answer some questions. It's easy to spin up a NetMiko script. You know, we've all done it, and with ChatGPT, it makes it even easier. Or leverage, PyEasy and create this source of truth. But when you have fundamental holes in the thing that you're automating, such as, well, if you run it like this, or you have to stand on one leg to actually automate it, or you have to change a few things to run it, or it only runs on my laptop, have you actually really automated anything? So the first thing we need to do was build a strategy. What are we doing, and why are we doing it? To actually step back and pause and think, should we be doing it, rather than can we, which is often the approach that engineers will approach things with. We get very much tunnel vision, and I'm guilty of it, I see a thing, I want to fix it. We never actually step back to think, why are we fixing it? What that actually does is it creates a bit of a warped vision of the sake of automation, automating something for the sake of automating. And we've heard it through a number of different talks, is that if it takes you longer to automate the thing you're automating, then you lose the value instantly. And it creates this warped vision of value and almost the them and us. We talk about this journey from network engineer to automation engineer and vice versa. And it's often a case of them and us, right? If we build things that we think they can consume and vice versa. We have a very clear path based off of courses and what we see on LinkedIn around what we should be automating and the right way to go. But actually no one ever really steps out to think, what do people on the ground, on the front line actually want and actually need? We need to progress beyond the pet project, the pet MVP, and actually think, what do we actually want to do? Now, I was brought in to build infrastructure as code. And you'll see as we go through this, I haven't actually done it yet, and I've been there a year. So the first thing we had was, well, tech debt, right? Everyone knows tech debt. As I'm doing my discovery, we go through the strategy around this is what we want to do, and we find that there's solutions in place. So you ask the natural question, well, who owns this script? Where does it run? Who wrote it? And 9 times out of 10, you'll get, well, he left last year. And that's completely fine. You'll have natural movement, it's expected, it's encouraged. The key is exposing those elements to the solution that make it difficult to understand and the nuances that come from that. So the natural second question is, well, so somebody knows how it works, right? If it's clearly that important and that fundamental that it's still running after somebody's left, surely somebody knows how it works. And the answer is, well, sometimes not really. It just runs. And it's an all too common problem myself that I have of, not writing comments or doc strings because, they're not cool. It takes a while, and you write code, you run it, it works, fantastic, you move on. But whilst that is the case, what you have to be conscious of is the obligation that comes with writing automation. Yes, you have a problem to fix, but actually the obligation is making sure that that is scalable and supportable beyond just you. And there'll always be that person, that whiz that can spin stuff up really, really quickly. But the trouble is that you risk resetting a lot of that progress if you don't make it supportable and iron out the inconsistencies that come with that. So the first thing we found was we have a netbox, fantastic. We have a source of truth. First question I asked was, do we trust our source of truth? And the answer was no. Or actually, it depends. And if that's the answer, then you don't have a source of truth at all. You have a place where you put your inventory. And that could be Netbox, it could be Excel, it could be whatever it is. Point still stands. If you don't have a trusted source of truth, then you may as well not have one at all. So for any automation, as everybody knows, you need a solid foundation of data, because any inconsistencies need coding around, and therefore creates that tech debt. So we found priority number one that we needed to fix. So first steps, what do we actually do? So discovery is the most important part of any automated activity. So I've said before that you need to take time to understand what people are actually having issues with on the front line. What is causing those hours to be sucked away? And what does it currently look like? More importantly, why is it like that? If we don't ask ourselves these questions, we'll find ourselves going down a rabbit hole that actually will then deviate that value away from the thing that we're delivering. What it turned out was that actually there was a lot of free reign. There was a lot of, we can do whatever we want. You know, it wasn't necessarily we needed to automate the right thing, it was that we just needed automation. And that then dictated that actually we need a pretty decent strategy here and a framework. So I did one, I delivered one. So this is our framework. Wanted to keep it super simple. I wanted to answer the question of, if anyone said, hey Dan, what does your automation stack look like at Gamma? What do you actually use? And I could show them this. And what this does is it breaks up the branch into different branches of actually what does automation look like across this cycle. So obviously we can dive down into each layer of these, and there's complicated schematics and UML diagrams that support all this. But effectively, at a top level, if I was to now come in fresh and want to automate at the company, what do we do? And simply defining that our inventory was in Netbox answers a very easy question of, well, we don't use Excel. And then almost you can start to then see the transition that actually if the answer was Excel, there's a project. Let's get it out of Excel into Netbox. If your testing is done for anything other than Renat, there's another project. And if you're deploying in anything other than Python, there's another project. So you can start to see now that whilst this is very, very high level, the actual layers that you go into that start to build out your strategy. What we actually did is we leveraged something called Cookie Cutter, which was deploying our standard template. So we had a situation where everything was already in Git, which was fantastic. But depending on who built the project and who their preference is, whether it was using poetry or requirements.txt, there was a load of different nuances. So we used Cookie Cutter to deploy a standard framework, a standard template to get started. Now all the projects began to look the same. They all had a source folder, they all had an app folder, they all had a logs folder in the right place. And now we had that consistent structure. We could then build in our CI/CD pipelines in Git things that linted in there. So everything then started to be tabbed correctly. We didn't have someone that preferred really, really long lines. We had someone and really, really short. Everything began to look the same. Everything then began to use the same framework. Because we leveraged poetry, we could move all of the packages that were just being installed from PyPy directly into our internal repo. And because we could then use Cookie Cutter, we could say, actually, on our automation platform, on our server, download from our internal repo, and we could get away from the bad practice. We standardized our development environment day one. It meant that anybody new that could come in could simply consume it. And the desire for instant impact has to be weighed up with the value of delivering. So this is the roadmap that we put out that effectively passed out our intent to deliver the projects that we said we would. So we wanted to start small, right? So we wanted to actually assess what we'd got. We didn't want to rush into anything. My background in ops helped prioritize what we wanted to deliver. The key piece of why automation doesn't stick is there's no end goal. It's almost like a continual improvement. And whilst everything can be refined and efficient, what you need to make sure is you have a definition of done. And that is the most important piece that I've learned over this course of this year is, what does done look like? Once you've defined a project, how do you know you've finished it? So there's no point, for example, having a YAML file that translates to a Yang schema and can push out devices to config to all the devices if You don't really know when a device has gone offline, and that was the sort of situation we found ourselves in at Gamma, is we had this desire to do automation, but actually we hadn't considered what basics were. We didn't really have fantastic monitoring. And it goes back to that first slide where I defined the scope. Right? I said we had a really clear scope of what we're going to achieve today. Now, my scope was to deliver infrastructure as code, but by doing so and figuring out and starting asking the questions of, well, we want a source of truth, which is netbox. That's not accurate. We want to build this automation and we want to run the scripts, but we have nothing to dump all the stack traces to. So clearly, it's priority number 2 is going to be monitoring. So what does our architecture and actual strategy actually look like? So this is a bit of a diagram that I put together that just basically shows our platforms at a high level as to what our themes across automation looks like at Gamma. And what this could then do is show how everything hooks together and the different relationships that each system has on each other, but we could then start taking these blocks, pulling them out, and actually building a bit of a project wrap around each of these to get them right. Because these are all the building blocks, and we've seen it throughout all the presentations, is you have to have a foundation of solid building blocks that you can hook together. We could then build objectives around these and then break these down into milestones. This was the infrastructure as code design that I put together. It's nothing fantastic. Using GitLab to render config. We talk about this whole process of upskilling network engineers to automation or downskilling or up. To me, it's all the same. You want to create a framework that people that want to do automation can consume, and people that don't want to do automation don't have to think about. So we have some really, really strong network engineers, and this whole thing of, well, you need to learn Python in the new world. No, of course you don't. You need people that understand Python, you need people that understand at a raw level things like OSPF and BGP. And you have some people that sit in the middle, kind of like me. And it's those people that you really want to leverage to say, well, you need to create a platform that either side can consume. And this is what infrastructure as code was for us. For example, a network engineer may want to build a static route, or let's say a firewall route on a particular firewall. We don't want to have to upskill every network engineer to understand how to build Fortinet firewall rules. So if we have that logic baked in behind the scenes, and you expose that mechanism and that framework to allow people to consume that, you can then open that up and allow anybody to build firewall rules. The idea here was that we use Git, the usual Git master staging dev type setup to commit to a repo, syntax check everything. It spins up Container Lab to drop the config on, verify things like the VRF look the same, the descriptions are all conformant, the host names are all conformant, and really iron out any of those issues that going from a lab to a live environment bring. And then we could kick off a run-out test to make sure that nothing explodes, and then queue up for operations to deploy with our automated pre and post checks. So I said that we came in with a clear goal, did a bit of discovery to figure out what do things look like, and we had to then reprioritize some of those projects. So now we had a clear strategy around what it is we were going to do. We had an end goal. How are we actually going to get there? So the first thing was monitoring and alerting. So I said there's no point building a platform, any automation, any processes, if you can't watch them, if you don't know what's going on. Things like how many Git commits have we done? When the Git commit is done and it's fed to the network, did anything break? Can we trace that all the way back to the change log? Can we tell, for example, when interfaces go down? And when they do they get pumped somewhere? Now, alerting at Gamma is a very interesting topic. We leverage some systems that basically output emails to an inbox. So actually what our monitor or alerting strategy looked like was inbox. And for anyone here that has done that, it's a very, very bad way of checking when stuff has gone wrong. So it'd be very difficult to deliver any kind of automation if all we did was just add to that problem, because we're going to need more people monitoring the automation than we fixed with it. So our ambition meant rethinking how we did monitoring and alerting as challenge number 1. So how we did that, we partnered with a company called Big Panda, and these guys specialize in alerting. They fit our use case really well. They said, send us everything. Any emails, any Alert manager, webhook stuff, REST APIs, absolutely everything, send it all in. And what we'll do is we'll combine everything together and we'll dedupe and we'll actually present what the root cause of that problem was. Now, that's outside of this topic, so anyone that wants to have a chat with about Big Panda, come and find me later. But at a high level, simply ingesting our alerts into Big Panda has allowed us to cut our alerts down by 67%. And that's in about 4 months. So if you think about that, if we think about your alerting strategy, whatever it is that you guys have in your company, Findo came to you and said, we can cut that in half, simply by using the platform. That's what it's done to us, and it's been really powerful. We're working to align our vision with Grafana, so we've put all our eggs in the Grafana basket to make sure that we can actually see what's going on. So when interfaces go down, when WDM lights degrade over time, when traffic moves from over here to over here, we can actually figure that out and actually see that in real time, which is going to then give us the ability to detect proactively and reactively in a really, really small amount of time. What this does highlight is the flexibility to pivot. Like I said, when I came in, monitoring wasn't on my agenda. But through discovery, we found actually it was a massive problem. And a problem that nobody really wanted to attack because it wasn't broken. It was just very, very inefficient and stunted our growth. But actually, figuring out what monitoring should look like and how that helped then underpin the future automation meant that we could sell that back to the business and say, hey, priority number 1 should be this. And I'm going to then put my hand up and say, right, let's attack it. Problem number 2, perfection paralysis. Now, it's something that I think everybody suffers from. There is an ideal way to do things. There's an ideal way or a better way to do everything. Especially for me, when I put out code, my team often laugh and say, this is horrendous. And yeah, it probably is. But the priority needs to be delivery, because waiting for something to be perfect stunts your growth. You'll never deliver anything. Now, there's some really good ideas floating around the company with how we should automate things and how things should look. Often challenged by, yeah, but you could do it that way, or you could do it this way. There's a better way of doing that. Yeah, absolutely there is. There will always be a better way of doing something. And sure, in an ideal world, changes in Netbox would be pushed to an event-driven pub sub architecture and pushed to the network, and yeah, it would. Fantastic. But that then means even the simplest of use cases grows this whole entire list of dependencies simply to just change an interface description. So you really have to contextualize what you're trying to deliver. There's a fine balance between creating half-baked solutions, but it's important to be really clear that how these align with the framework and making sure that you go back to your scope of actually what are you trying to deliver? What is the bang for buck? For me, you prioritize delivery, you reiterate and go back round and make it more efficient. But it is imperative to deliver that story to sell the automation. And the third is the culture. So automation can be resented because there's so many different ways to do things. And the biggest challenge for me, like I said before, isn't technical. The barrier to entry to automation is so low, thanks to all the great work that people in this room put out to LinkedIn and all the courses that everyone puts together. Anyone can pick up a book and overnight become, the ability to build a Python script, and that's fantastic for the community. But that's not the complicated bit. The complicated bit is actually selling that story. And for me, especially at Gamma, you need to make sure that you take people on that journey to make sure that they're part of it. I've said it a number of times before, you have to figure out the thing you're automating, how that impacts their life, their world. Why do they care? And then getting the right buy-in, therefore, is not only at a senior level to get that funding and to get the time commitment from the upper layers, but also then how that translates to the front line, how that then helps them on a day-to-day basis. And ultimately, to be brutally honest with you, if you're automating the right thing, it should be dead easy to sell. You shouldn't have to spend time convincing anybody. Because if you have to spend time trying to sell what you're automating, then you probably haven't asked the right questions. So our 3 projects that I focused on over the last year, we'll give a bit of a highlight of just why we've done these 3, but the first was our API gateway. So as with any ISP that obviously I've worked at too, but looking across the industry, one of the common problems is legacy systems that have just been preserved through the years, all the way from TDM, PDH, all the way through when IP was born, and now into the new world that we're in. So one of the challenges that people have, or companies have, is how do we get information out of them? How do we get information in them? How do we stitch them together? So we built our own API gateway. And what that is effectively a way of consolidating some of the more commonly seen scenarios and themes. So for example, one of the things I noticed was I counted probably around 70 scripts that all went to Netbox, authenticated, got a whole list of devices, pulled them back, chucked most of the list away, and then did something with a subset of them. And that's fine, that works. But when you then go to a world in Netbox Cloud, which we'll come on to in a bit, where they charge you for API calls, actually that's not a great model. And if you think then the barrier that you have to entry of that, of somebody that doesn't understand requests or Python or anything, but they want to do automation, they then get presented this block of code, they don't really know what it does, to say, well, okay, you have to integrate, you have to use this to then pull a list of devices. It's just not a great selling story. So this API gateway was born as a bit of a, let's take all the good things that we can see across the company and consolidate them into one place, and then make them exposable and consumable over something as simple as going to a website. So this is what it looks like. We created it using Fast API, JWT. It's nothing fantastic. It's not, it's reinventing the wheel around things. The aim was just to provide a consistent schema to everything, to provide a data cache. So rather than everybody going to Netbox and pulling that data all the time, the API gateway goes to Netbox, pulls it once every hour, puts it into a data cache. We then redirect those users to that data cache, so they then get the same information back. Something as simple as that just redirects that resource request. And it allows us to manage the blast radius of any upstream systems. So someone spoke about Netbox being upgraded and it breaking some workflows. It doesn't happen here. Netbox went down the other week, nobody noticed. Because we have that API gateway in front and we have that data cache that we could bring in. It's a really simple use case, but one of the biggest advantages we have currently of using something like this is we have an OSS BSS system that doesn't really expose its APIs, and it's very hard to interact with. It's the same story that everybody has. Now, that holds a configuration of what the network should look like, and we simply want to move customer from over here to over here. Do we think that system knows exactly what is on the network? Of course not. That network customer has changed over time. They've had their MTU modified. They might have had an extra static route put in. And so you have this gap of, well, we need to use this system because it's embedded so much into our company. But how do we actually validate that against the network? And this is where the API gateway comes in. So very simple check. Because it's internal and it's all developed internally by us, we could simply say, okay, send us a request. We'll then go off to the network, we'll check the config, and we'll push it back, and we'll tell you if there's any dependencies based off of what you have said you think the service looks like. And this has been used in the last 2 months, I think, over 2,500 times. And when you start to put a figure on that, around actually, if you think in your head, how long does it take to log onto a router, do a show run, or whatever, get the customer's config, put it in a text file, vim diff it, or whatever it is you want to do, 5 minutes, at least. So you then multiply that up and scale it up, and you think, actually, something as simple as spinning up a fast API endpoint with this functionality in, it pays for itself. And that goes back to the challenge isn't technical. This is easy. It's finding that use case. Because had this not existed, that would be a person having to do that. And that's how you sell that automation journey. So this is just an example of an endpoint. So this is one of our endpoints that we use for Prometheus service discovery. We leverage Netbox as our inventory, obviously, as many people do. The idea here is that when people spin up stuff in OpenStack, OpenStack goes and sends that off into Netbox. Netbox, it then tags it with a particular tag, and then that tag is then picked up by this endpoint using the cache, and Prometheus then can monitor it instantly. So we've got that entire life cycle. And this is just, again, another example, a real simple use case where Prometheus is expecting a certain data structure. Netbox returns a certain data structure. We're just doing that translation in the middle. It's wrapped up with JWT just to make things a little bit more secure, and we have R back in there just to, again, limit who can talk to different endpoints. But what this has done is it's given us a really solid foundation to actually expose any automation to anybody and not need them to code. So the second project we picked up on was network reconciliation. So this is all about making that source of truth trusted. How do we get the data off the network into Netbox, and vice versa, because Netbox sometimes was the source of truth for that. So this is what we come up with. It's a reconciliation tool. Again, nothing fantastic, but it takes what's in Netbox, takes what's in the network, combines the two. And it does certain things like validate templates. So we have templates around what should our host names look like? What do our interface descriptions look like? Are they all uppercase? Is it dashes? Real simple things like that that we all have to code around because somebody prefers underscores or somebody prefers uppercase. We validate those and we have those sat in that. And so this process actually validates either of those. At the minute, we don't trust either. So what we do is if anything looks different, so let's say the host name doesn't quite match what's on the network or vice versa, we then pump that up to a Jira board that allows people to utilize those swim lanes to track that fault through. Eventually, we'll get to a point where we do trust it, and we can turn on auto reconciliation. And this gives us a real good framework that means that people can make changes in Netbox, they get reflected on the network, and vice versa. Engineer pulls a card out and changes it, the serial number then gets back populated up through Netbox. And the third project was auto checks. So we have a really solid testing strategy at the minute with daily checks. It's built on PyTest. What it does is it basically goes around and says, has the network moved? Does it look like how it did yesterday? Does it match what we expect it to? So it kind of monitors state. And it's a really, really great tool, really powerful tool that detects anything that doesn't look quite right. The framework it's built on doesn't really allow it for a pre and post check. For that, we had JSnappy, which again, some people have used. And again, it's a fantastic tool for Juniper. What about everything else? So we wanted to create a framework that basically did both of those things together. And that's where Gamma AutoChecks was born. An agnostic tool that people could consume that hid all the things that we know change. When you reload a router, all the time it gets reset. Any check you do in a period of time is going to have the LDP labels mismatch. Things move, right? The network is a moving target. We know that stuff changes, so let's hide it, right? And let's make sure that what is actually presented to the user matters. So the idea here was to give a really clear output to the user of, did the thing I just do break? And that's effectively what we see here, a real clear snapshot to the user of, here's the state of the router before, here's the state of the router after, and a real one-shot check of eyeballing anything that happened. Now in the back end, obviously, we've got all the structured data for people like me that want to go and get that bit more of a fluffy feeling that I can see the raw command outputs. You can see all those timers changed, but that's effectively minimizing that downtime. And what it allows to do is for router upgrades, for example, we can upgrade a router, run the check, see all the ticks, and move on. Now you'll notice there that CPU is actually X'd. That's on purpose. Obviously those numbers don't match, but what we've got is thresholds built into here. So we know things move, we know CPU is going to go up and down. So we've built thresholds into here to hide some of the actual known changes. So that's kind of what we've delivered over the last year at Gamma. What's next? So some of these things that you've seen probably belong in the cloud. We've developed them on-prem at the minute just to see how it goes, really, I think. And I think that over the next year or so, we're going to move some of those workloads into AWS. We're trying to sort of figure out what lives there, what belongs on-prem. We'll probably end up in a bit of a hybrid situation. Partnering with Netbox. So like I said before, we're going to go Netbox Cloud. So we have at least 4 or 5 installations on-prem, because testament to how easy that thing is to install. Everyone spins up their own version. So we're going to consolidate all those into Netbox Cloud. Continue our automation strategy, so building out our monitoring capability, continuing with our alerting and getting that right down, and grow our orchestration platform. So having simple use cases such as being able to, I don't know, if we get an alert for a server, the one I use quite often is if a server runs out of memory, you get a Prometheus alert in there, hits Big Panda. First thing I'm going to do if I get an out of memory alert is log onto the box, probably remove everything /temp and do a Docker prune. We don't really want engineers having to do that. If the steps that you take after certain alerts are predictable and known, then let's have something do that for us. So we want to build a platform that will help facilitate that. Big Panda will push the alert to the platform, that will process it, and then when it hits the engineer's eyeballs, the usual's already done. So we kind of then move from here's a routine check approach to more of a here's an exemption approach. And hopefully that's going to then cut down the time that it takes for fixing really simple problems. That is me. So any questions?
Yeah, thanks for the presentation. Yeah, actually, I want to ask about these auto checks. Yeah, because sometimes, when I'm thinking about these networking auto checks, it is kind of the application with the alarm management system, right? So, for example, like you are checking the cards daily, for example, in the example, but actually, it's also like kind of alerting with the management system that you are getting. So, how you can find the use cases for auto checks, which is not duplicating with your alarm management system and that kind of stuff?
Yeah, so we're trying to partner with, we're on the brink of partnering with someone, NetPicker, which are the guys in here, to leverage a little bit more of the things that you want to check realistically. So things like, for our platform at least, Prometheus services is running, and really any custom application metrics that you want to check on a daily basis, they can all be consumed within this platform. Effectively, we want auto checks to be the thing that anything that gives you that fluffy feeling in the morning. We all know that when we wake up, we have that system that we check that says, today's going to suck, or today's great. It's those things, it's that thought process that is going to go into auto checks. And some of those things are going to have to be derived, right? Some of those things aren't static values. For example, we can't, the LDP labels is a brilliant one. LDP is going to change over time as your network grows. You don't really want to be hard coding any values in there. So you want to kind of derive some of the stack traces or some of the thresholds that you have based off of the use cases that you have for those applications. And that's kind of where I see auto checks sort of absorbing all of those routine elements. And the purpose of it really is to allow the people that know what they're doing to input the logic and just simply run a script that says, yeah, everything was great. When you deploy something, you don't really want to then spend as much time checking that it didn't break anything as you did deploying the change. And that's kind of then flipping that time into actually focusing on doing cooler stuff. Hopefully that answered it. Lovely. Thank you very much.
We're going to wrap it up there.